In this video, we will talk about Homework 7's problem 8. So, from the problem, we know the definition and some properties for the Poisson process, and so we use the process to find a the estimate of xt, and b the relation between t1 and t2, the autocorrelated correlation. So for the first one, since we know the property for it is when xt is on into t, and it follows the form as the summation of from k to 0 to infinity of e lambda k lambda to the power k and divided by k factorial and equals to 1. So this one can be considered as the derivative of k from k equals 0 to infinity. Sorry, is to the power of derivative on the lambda, and is equals to from k to 0 to infinity. And here, to get the derivative on k is k here and minus lambda times lambda to the power of k divided by k to factorial, which equals to the lambda. And this one, and the derivative here is equals to 1, which is, if we didn't find the derivative, it is the summation of k is equals to 0 to infinity, and k times e to the power of negative lambda times lambda times k factorial equals to lambda. And this one, in this part, it is equals to the estimate of xt equals to lambda. And we can solve it but as the summation from k to 0 to infinite k times lambda k to the power k factorial equals to move this part, since every element here has it, so times to the right side as into lambda, and then get its derivative as d to the d lambda equals to find the derivative on this side, on the right side, which is lambda e lambda, and which is equals to e lambda plus lambda e to the power of lambda. And if we find the other one, so when k is equal to 0 to infinity, and from the second order is a second order from k squared, and it will become lambda to the k minus 1, k squared times lambda to the power of k minus 1, and divided by k factorial, which is 1 plus lambda e lambda, same as this one. Solve both sides. And move this one to the left side, which is k equals to the power of to infinite k square times e to the power of negative lambda k minus 1 times k squared equals to 1 plus lambda times lambda. So we know this part is equals to the covariance, the variance of xt. So estimate x squared equals to variance and equals variance minus lambda squared, and that will equals to minus lambda. So we can finally get the result that the estimate of xt actually is equals to lambda, and estimate of x squared t, which is the variance, this one is equal to 1 plus lambda t times lambda t, and the variance of it is lambda t. For the second part, to find the autocorrelation between R1, T1, and T2, and we can find the estimate of xt1 times xt2, which can be similar as xt2 minus xt1 plus xt1, which equals to e xt1 times expected value of the estimate of xt2 minus xt1 plus s squared t2, which is equal to lambda t1 times lambda t2 minus lambda t1 plus 1 plus lambda t1, which is equals to simplified as lambda times t1 plus lambda t1 t2, when that is when t2 larger than equals to t1 to make it make all the formula positive. And if t2 less than equals to 0, so t1 and t2 will be on the offset, so which is lambda times t2 plus lambda t1 t2.